Hi all. This video is to go over a couple of problems from the handout and show how to use the 8 steps for hypothesis testing. So the first part is to read through the questions carefully to make sure that we understand what parts we're looking for and what kind of test we're using. Just as a reminder, the 8 steps we're looking for are these 8 steps that are on the handout that was sent out. The first idea here is to ID the claim in math so that we can figure out which variable we're going for. And once we figure out the variable we need, the rest of this is reading through the problem and making sure we're following the correct path. Okay, so let's read through this problem and see if we can figure out what pieces they're asking us about. So a local group claims that the police issue at least 60 parking tickets a day. To prove their point, they randomly select 2 weeks. Their research yields the number of tickets issued for each day. The mean of the data is about 62 or 60.2, and the standard deviation of the data is about 13.4. At alpha equals 0.1, test the group's claim. Okay, so now let's follow our 8 steps. The first step is to ID the claim in math. So we want to use one of these symbols to be able to figure out what they're claiming. Okay. So I'm going to have to move away from that problem a little bit. They're trying to claim that the police issue at least 60 parking tickets per day. So they're saying that on average, there's at least 60 parking tickets a day. So step 1 is to write the claim in terms of mathematics. That would be the claim, nice and big so we don't lose it, is that mu is at least, so more than or equal to 60 tickets per day. Step 2 is to write the opposite of number 1 in math. So the opposite of greater than or equal to is less than 60. Step 3 is to write the H naught and HA, recalling that H naught will always have equality and HA should never have an equality, and that HA will tell us what tail we have for our test. So HA is either, H naught is either step 1 or step 2, whichever one does have equality. So H naught must be greater than or equal to 60 because equality is allowed there. HA must be the other one because these two are opposite. These two must also be opposite. So is less than 60, and we can confirm that there is no equality here. Going back to our cheat sheet, we see that this one should have equality and this one should not. Okay, so then based on this, we can tell the number of tails. So this is a left-tailed test, meaning that the area or the critical values will be located in the left tail of a normal distribution or of whatever distribution we're looking at. Note that we don't have to remember the left-tailed test. We can always just go the direction the arrow points. Okay, as long as we highlight that on our distribution, we'll be fine. So if you're like me and left and right are always a struggle, that's a nice tip. Okay, step 4 is to make sure we know the significance level. So looking at this, it told us in plain language that alpha is equal to 0.01, which is nice. Sometimes it will say the significance level. So we just have to realize significance level and alpha are the same thing. So alpha is equal to 0.01. Step 5, we need to write down the function, meaning what are we going to use in Excel, or the table if we're using tables, and the test statistic. So in step 5, I can go back to my cheat sheet and follow this. So the function, this green part, is always telling me to look at H naught. H naught, I need to see what variable H naught is using, and that will tell me what equation and what function in Excel or table in the back of the book I should be using. So my H naught has a mu, so I should be using the T dot distribution or inverse. I should be using this equation for the test statistic, and this is all part of the upper part. Okay, if I'm using the tables, then I'll be using the T table. So I'm going to say the T dot INV or T dot dist, depending on what method I use in step 6. And the equation is T is equal to X bar minus mu divided by S divided by the square root of n. The next thing I want to do is make sure I can identify all these pieces for this big equation. So x bar, mu, s, n. Going back to the problem, they found the mean to be 60.2, so x bar is for the sample, so that's 60.2. Mu, we decided up here, is greater than or equal to 60. Since I need to be able to plug in a specific value, I'm going to use the equal than or equal to value. So mu is 60. S from the problem over here is 13.4. And finally, N, they collected data over 2 weeks. So that is 14 days, since our argument is the number of tickets per day. So if I want to use, say, Excel to be able to figure this out, I would equal 60.2 minus 60 divided by 13.4 divided by SQRT for square root of 14, and then I want to wrap that denominator in parentheses too. Okay, so if I do that in Excel and hit equals, it should give me 0.056. Before we want to move on, we want to take a look at this number. Remember, when we're doing a hypothesis test, we're looking for numbers that fall inside the outer regions, the tails of our distribution. I know this is a t-distribution, so it's always going to surround 0. So this number seems like it's awful close to 0. So this is probably not in a tail, meaning that I probably won't be in a rejection region, meaning that I probably won't reject the null hypothesis, which is the at least 60 tickets a day. Which makes sense because my data seem to support that. Whereas I took these 14 days, I got 60 on average, and I'm making an argument that it's 60. So the small number that I got here doesn't seem strange because these two numbers are very close together. Okay, continuing into step 6, I cheated a little. Technically, this calculation is part of step 6 if you're following the flowchart. Just put an arrow there and fix that. So the flowchart says step 5 is just to write down the equation and the table that you're going to use, or the function you'll use in Excel, just to help keep you organized. So we cheated a little and did the plug and chug part already. So we're supposed to plug and chug our test statistic. Plug and chug, that just means what we did, put in the values for the variables and do the calculation, and draw a picture. Then we'll choose between p-value and critical value. A p-value test compares the area associated with the test statistic to the area that alpha is. Remember, alpha is an area inside the tail. If our p-value is too big, right here, is too big, then we will fail to reject H0, because our rejection regions are inside these highlighted area. These are rejection regions. So the area is exactly the same size as alpha. So if the area associated with my test statistic is too large, then I would not fit in this rejection region, and so I would fail to reject. The critical value method instead has us find a critical value associated with alpha. So a critical value method has us find the critical value that starts and stops this shaded region. Then all we have to do is compare our test statistic to our critical value and use a number line argument to say either we're on this side or we're on this side, on the shaded side or on the not shaded side. If we're on the not shaded side, then we're not in the rejection region, so we would fail to reject. If we land in the shaded side, then we are in the rejection region and we reject H0. So let's go back to our problem. We'll go ahead and use both methods, the p-value and the critical value, so that we can see what they both look like. So remembering that technically this calculation is part of step 6 and we've fixed that with an arrow, we're going to go ahead and use the p-value method. So remember, p-value, I'm going to calculate an area associated with this test statistic. Because I'm using the t-table, I'm going to use t.dist of my test statistic, the degrees of freedom, and 1 for cumulative. It's always 1 in our class. So it's specific for this problem, should be t.dist of 0.056. Degrees of freedom is n minus 1, so since n is 14, degrees of freedom is 13, and comma 1. Before I do this calculation in Excel, let's go ahead and draw a picture associated with it. This is the t-distribution, so I know 0 is in the middle. I have a left-tailed test, which I recall from step 2, told me that it was a left-tailed test. So I have a left tail, and the area of this tail over here is alpha, which is, in step 4, 0.01. 0.01. So essentially we have a room of our house that is this much square feet, because remember alpha is an area. So we have a room in our house that's, let's say, 1 square foot. We're trying to make sure the rug, that is our p-value, will fit in the room. So we need to calculate the area for our rug. Okay, to do that we need to make that calculation in Excel. And we get about 0.522. Okay, so this is essentially over 50%. It's obviously much longer than this. So I have a rug that's 50 square feet and a room that's only 1 square foot, so it's never going to fit. I'm definitely outside. And if I add this to the number line, I know that it's somewhere over here, more than 0, but very close to 0. It's more than half the graph is to the left, so it makes sense that my area represents more than 50%. Doing a similar calculation with critical values, instead of finding an area, I would find the critical value that's associated with alpha. So to do that, I will use t.inv of alpha and the degrees of freedom. So for this problem, it would be t.inv of 0.01 and 13 again. Doing that calculation, I get about negative 2.65. Okay, so it's 1, negative, which makes sense because I'm a left-tailed test, and 2, pretty far away from 0, which makes sense because I have a very small area associated with it on the left. So to use the two tests, going back to our cheat sheet, if we compare our p-value to alpha and find that the p-value is larger than alpha, we fail to reject H0. If we compare our critical value to our test statistic and find that our test statistic does not fall in the rejection region, we fail to reject H0. So let's check. Here, this is much larger than alpha. And for this picture, we know 0 is in the middle. I have an area over here of 0.01, and my critical value cutting off that area is negative 2.65. Since my test statistic is 0.0522, I know that there's no way that I fall into this rejection region on the left-hand side. So either way, I failed to reject H0. So step 7 is just formally writing that down. Unzoom. Okay. So step 7 is either reject or fail to reject H0 based on the results from step 6. That's a typo, or a write-out, if you will. So based on the results from step 6. So step 7, we fail to reject H0 because usually you list one reason because you've done one of these tests, but in this case we did 2, so we'll go ahead and list them both. First, we did p-value. So because our p-value is larger than alpha. And second, we did critical value. So for critical value, we'd say our test statistic did not fall in the rejection region. Okay, so step 8 is one of the trickiest parts of the whole thing, and that is writing it in regular words, leaving behind all of the statistics and just writing the statement in regular English. So we compare step 7 to the null hypothesis to the claim and decide if the data supports the claim. All right, so going through here, in step 7, we fail to reject H0. So let's go back up and see what H0 is. So H0 is sitting right here. Mu is greater than or equal to 60. I'll go ahead and put a little smiley face next to H0 because I failed to reject it, which we can think of as supporting. Just like as a jury would say somebody is not guilty rather than saying they're innocent, we would say fail to reject rather than accept. Now we just have to compare that to the claim. We can see these two things match, and so I'll give the claim a little smiley face too to help me remember that I'm going to support the claim. So in step 8, we have enough evidence to support the claim that the police department issues at least 60 parking tickets per day. Okay, and that is a complete hypothesis test with all 8 steps representing the algorithm for being able to complete the test. Regardless of which one of these problems we're doing, the test will follow the same layout, meaning we will always follow these 8 steps. Once we decide what variable to use, we're following the same steps using either whatever table here is appropriate. It doesn't make any changes to how you decide which tail there is, right? That's always based on HA. It doesn't make any changes to how p-value and critical value work. It doesn't make any changes to whether or not you reject or fail to reject based on the results from step 6. And it doesn't make any changes to how you set up the conclusion. So depending on the variable, the only changes you'd really see are the variable being represented in H0 and HA and the method used to test. I hope you find this video helpful for being able to organize how we're doing these hypothesis tests and to be able to see the usefulness of the 8 steps to keep us organized no matter what kind of hypothesis test we're doing. That way we can think of it as hypothesis testing rather than several sections of information that's easy to get confused.